Good morning. Yay, emotes. So I'm just looking through the Prime gaming loot. There's an Agario package. I didn't realize they were doing that. That's awesome. It's like a throwback to 10 years ago. Wow. And if you're all sick of synthwave, electro, techno-ish music, this is a nice little compromise I found for the intersection of my musical taste to what other people find acceptable. Alrighty. We should probably get going here, huh? 9 o'clock. Good a time as any. Ah, okie dokie. We ended about here last time. So we were starting to talk about Agile. And we also did a little bit of a GitHub demo, right? So I guess one thing I should ask before we get too deep into things, um, anybody have any questions or issues with the GitHub expectations that I have? I know it's new for some of you, it's old hat for some of you as well, so I'm not expecting you to be an expert coming into this. But if you have any questions or something doesn't make sense, please feel free to let me know, either through the chat. I am more than happy to stop and talk about it, since if one of you are having problems, there's probably multiples of you that are having issues. And I've been using it for quite a while now, and I'm very pleased with how nice the interface is for Git and GitHub. To me, it's a lot easier than something like Subversion or any of the other configuration management systems that are out there. Plus, you get a nice little portfolio page out of it at the end of class, too, if you don't have one already. So, again, let me know if you have issues with that. Otherwise, I'm going to assume everybody's okay with it. If I don't hear anything, then either you don't want to ask me or everything's fine. I did notice some people already started inviting me to their repositories, so that's good. That means some things were hopefully clear enough for you all. But otherwise, we can move on. Right, you still have some time for that assignment too. I just wanted to kind of bring it up early because the earlier we talk about things, the less chance there are for problems, right? All right, we were actually here, not there on the last one. I absolutely agree. Um, it is very, very reliable. I don't know that I've ever had any issues with uptime or problems happening with Git. I mean, if there's been a problem, it's been my fault because I screwed something up, right? I put myself into a situation where I had a merge conflict or something of that nature. And honestly, what I've been doing, this is a bit of an aside, but for myself, I've got class materials I'm working on, I've got research I'm working on, I've got little hobby projects I'm working on. If it's code related, it all goes into GitHub. And when I'm done for the day, I just do a push to GitHub. And then, if I am going into the office or something, maybe going to use another computer somewhere else, I just do a Git pull. And then I have all my content that I need to work on right in front of me. Assuming it's not like a cloud service like Google Docs or something like that. But it's kind of been really nice, being able to go from like a home computer to a work computer or something like that. Yeah, if you have multiple computers. And it's nice for backups too. And it's easy. And it's up all the time. It's great. I was kind of worried when GitHub was going under a couple years back, and fortunately Microsoft bailed them out. Anyway, I guess one thing I can mention too with this as well, another aside, if you're not into the whole GitHub idea, but you like the software, maybe you don't want to put it into a public repository, you can run your own GitHub servers. So there's something called GitLab, which is a Ruby-based environment, and it's like a 3 or 4 click deployment onto a server. So if you have a spare computer or you have computing resources, you can run your own Git server. Sorry, GitHub-like server. You can run Git anywhere. It's just a Linux package at this point, but GitLab is pretty resource intensive, I've seen. I have run one or two before, and it tends to be very heavy in terms of like RAM requirements. It's very strange that something like that is so big. But just thought I would throw that out there too. Come on, F11, GitLab. Just I like kind of pointing these things out in case if anybody's interested, because it is kind of cool to run your own server software too. But it's basically GitLab, or sorry, GitHub, all of the fun little aspects that you get with GitHub, except it's run by you instead of GitHub. So check it out if that's something you're into. If not, you probably want me to stop talking about Git and start talking about Agile, which I'm sure we are all excited about. So this is where we ended up. We were talking about the Agile triangle, and I was kind of glazing over all the very particular aspects of Agile, but we're focusing on collaboration and basically communication between developers, customers, product managers. Everybody is kind of self-organizing, very free form. There is a lot more to it, but it's intended to be very flexible, right? And we kind of ended up here. Does Agile help us with these 3 points on our triangle, right? Do we get quality and value and constraints? Basically, is this the magic fix to all of our software engineering problems? And that's kind of where we're at here, right? Is Agile this miracle pill, this there's a panacea, silver bullet, whatever your favorite term is for the thing that is going to just fix everything? People have thought that Agile is that for software engineering. And the question here is it that simple, right? Do we just start writing code? Do we have our daily stand-up meetings with our team? Do we have a fancy board behind you with a bunch of post-it notes where you move tasks from design to implementation? Maybe you want to work on this today, work on that today. Is it that simple? Do we just start writing code and we have a magically working project? He said with a very sarcastic inflection on his tone. And the answer, which may surprise you, given how sarcastic I'm talking right now, no, it's not that easy. It's never that easy. Um, Agile has a lot of benefits. It has a lot of downsides too. Just like any other software engineering process, there are trade-offs. You trade off the rigorous, extremely, you know, siloed type of project with waterfall where you have different processes that you go through, you iterate over time, and then you get a working project. You have that guarantee of structure. In Agile, you're not necessarily left to your own devices. It's still kind of a rigorously defined environment, but it's a lot more flexible, a lot more freeform, and there's a possibility things can get lost along the way, which is a concern for a lot of people. So it's not that simple. Now, I've got a couple of kind of like promo-y type figures for you in the next slides. Here is a, let's say, lean enterprises. So lean is kind of a, not necessarily a subset, more of an offshoot of Agile. But effectively, you have a good view of an Agile type environment here. And this is everything that we are going to be doing in an Agile-like environment for a project. We've got these very nice kind of corporate graphic style visuals here. But basically, what do we care about? We care about things at the portfolio level. We care about large solutions. We care about specific programs. We care about particular teams. Basically, there is going to be a team-like structure with specifics on how to coordinate between team members at various kind of like levels of complexity. So portfolio, this would be company-wide, right? This would be something the entire company is doing, that we are moving into autonomous, right? We are developing the next generation GPUs. We are in healthcare. We are in automotive. We are in aerospace. Whatever your company's doing, you're building up a portfolio based up around themes, around budgets, around everything that you have going on here. And this is very, very high level. You're up high in the company if you're dealing with this kind of stuff. Depending on your approach, you might call basically business portfolio items or strategies or basically these kind of guidances that your company's moving towards. You might call them epics, which is to me kind of buzzwordy, but you have people who are epic owners. This is some of that agile terminology that kind of makes me grind my teeth a little bit because why do we need new terms for this? But, high level, you have people overseeing these kind of themes. You start delving down a little bit into the solution layer. We're going to bring in architects. We're going to bring in management. We're going to basically start trying to figure out how we can structure our projects so that our teams can really bite into them, right? And again, this hopefully is kind of sounding similar to what you would know and expect. It's just we have different terms for things and we have things in different places, right? Our little process boxes are getting moved around, different arrows into and out of them. This figure here looks very, kind of cluttered, but very graphically pretty. We're just moving things around and making it a little bit more flexible. You start moving down here though, and this is where it gets more interesting for you because this is kind of the entry level to mid-level engineer range where you get into your teams and your programs. So you see here a dev team, you see a product owner, you see a Scrum master. Scrums are going to be basically how you develop your projects, develop your tasks, and the person in charge of that structure will be called your Scrum master. This person, this engineer, whatever their role is going to be in the company, they're in charge of overseeing this process. They're basically like your quality manager, except it's very agile specific. So they're going to run the Scrum meetings, they're going to run the Kanban board or something that nature. Basically, they're going to ensure that you follow this process correctly, right? Again, it's still software development. It's just we have, again, different kind of flavors of how we're going to do it. Other thing here too you see is that there's a lot of iterative development. So you see this kind of little Scrum circle, and we'll talk about this here in a moment, what Scrum is, because I keep throwing this term out without really explaining it. Basically, it's a bunch of little sprints for, starting a task to getting a checkpoint in your project done. I'm going to guess some of you have had term projects where they are structured as sprints. So sprint number one is pre-midterm, sprint number two is maybe the 2 weeks after the midterm, then you have another sprint till the final. Basically, you have a set of goals that you need to achieve by the time this sprint is done. And then maybe you do a release, maybe you do a checkpoint, whatever your process is, you're going to have something done at the end of that sprint, hopefully correctly. And you see a whole bunch of these kind of little iterations down here. And we're not going to go into the details of one versus the other type of Agile because at this point there are just so many different flavors of it that if you learn the terminology for one, it's going to be different in the next one and different in the next one. The concept is collaboration and a little bit more freeformness is basically the takeaway that you need here. One other thing that's going to be helpful in here too that will be more common across these is a continuous delivery pipeline. So you have seen, right, I mentioned last time like a CI/CD type of thing where software is constantly built, it's constantly checked. Like you would push it to a Jenkins or a Travis CI type of pipeline where I submit my code, it is automatically built by this script. It is then automatically unit tested, automatically integration tested, and basically you send things to a pipeline and hopefully working software comes out at the end. This is kind of one of the, generally an Agile framework will have some kind of pipeline like this. Just be aware. One other thing here too, and I feel like I've said one other thing like 3 or 4 times already, um, is that this is in terms of history, it's still the newcomer to software engineering, right? So Agile is still kind of the new and exciting thing. And it still has learning pains and kind of growing pains, and it doesn't always work at scale. It tends to work for very um, like fast moving project teams. It's very good when you have very flexible requirements. It's very good when you have like a small core group who work well together. Or one of the other things we're never going to really talk about here is the makeup of your project teams. Your term project teams or project teams in general. One of the requirements of Agile is that your team has to gel, meaning that you have to work well together. You don't have to be best friends, right? You can go home at the end of the day and not talk to your coworkers. That's perfectly fine. But you should be able to work well together when you're in the office, right? If everybody works well together, this thing gets done on time and under budget. If people don't work well together, Personalities collide, projects collide, tasks collide, and you end up with a horrible, garbled mess. And this is one of the things that Agile can suffer from, is makeup of, basically a team that doesn't work well together. So kind of the key takeaway here is that it is good in small, well-organized teams. When you bring it up to scale, it can work, but it can be a struggle. Basically, everybody has to buy into this notion, otherwise it's kind of going to fall apart. And when I describe it like that, I can think of it like communism almost. Everybody has to do their part, right? Okay, so nice pretty picture here. Let's look at what Agile actually can mean. And this, again, I keep caveating with this. This is one perspective among many, right? So effectively here, we have kind of a small framework for how you would actually do an Agile development project from start to finish. So we have 1, 2, 3, 4, 5 phases. You may iterate each of these phases depending on your project. Again, I'm going to have a depending or unless if this happens or blah, blah, blah. Basically, there's a lot of flexibility with how you transition between phases here. So you start out at the Envision phase. Basically, what is the product you're making? What is the scope? What are the boundaries? Come up with a plan for releasing. Come up with a skeleton team. Basically, here are the key people we need, and we can kind of add in others as we need them. Basically, structure your project mentally. That's kind of what you are all doing right now with your proposals, right? Most term projects, most engineering projects have a proposal, and you get the super condensed light version for this class. But what are you doing? Who are the people that are involved with your project? What is this thing going to do? And even more importantly to me, as somebody who has done project management and has been a project engineer, the vision of the project is great, but what are the constraints? What are the boundaries of this project? Where are we going to stop development? Right, we talked about system boundaries a while back. Make sure that you scope your project appropriately, otherwise it's never going to get done. Right? You get into that feature creep thing where, okay, we developed this really awesome demo of a one-room single-player game. The physics are fun, the enemies are beautiful. Hey, let's add multiplayer. And then that takes another 2 years because it's just out of scope with the team that you have. And I'm not picking on any of you that said we were going to do multiplayer because it is possible. It's just a lot of extra complexity to keep in mind. If you're thinking of doing multiplayer for one of your games, if you did think about proposing that, be aware it's probably going to take you 2 to 3 times as long to get something functioning, just as a forewarning. Even if you are experienced with it, it is a lot of basically you're adding on network management and latency and making sure you have a server doing all the sanity checking. And basically, it's a lot of headache, just as a heads up. But if you feel comfortable doing it, fine, go for it. But just be aware, it can be hard. Anyway, figure out who your teams are, what your project's going to be. Then go into the speculation phase. Basically, identify what are the pieces of this project. Agile calls them user stories or stories. Effectively, their goals or high-level requirements. Basically, this thing has to happen on our project. My coffee cup will have hot coffee in it. My water cup will have cold water in it. My blank wall is a color that I can key out to make it look like I'm floating in space or something like that. My phone app will have a button that screams. Yeah, I've got a little screaming goat here. That's the best I can think of today. So my screaming goat will scream. It's a tribute to that Taylor Swift song there. But basically, what are the things that we have to hit? And then what is the release plan? Then you get into this explore phase where basically, again, we are iterating. Let's work on our stories, which again are basically goals. How are we going to execute them? What are the pieces of these activities we have to do? Then go into development. Program. Do some testing. Test-driven development is something we'll get to later on. But this is an approach where you write test cases first and code afterwards. I guess just to make sure that I've got people here other than our demonic pancake. Anybody ever do test-driven development before? I know that some of you have, last semester when I talked about TDD, some people had done it in the past. I'm curious if any of you ever been introduced to this topic, I guess. No. Okay. Have you done JUnit though? Because I know the Java class kind of changes sometimes. Some of you have done JUnit. Okay. So if you have done JUnit, you should be quite comfortable with test-driven development. Okay. Yeah, that's what we'll do later on in the semester. Basically, you write your test cases first. So imagine you're writing one of your projects for class and you're doing it in Java, right? Let me pick on the GUI dancer, the GUI dancer team. So you're going to make a little dancing stick figure in a GUI, I think, right? If you're doing a test-driven development type of project, you would write JUnit test for that first, and then you would write everything else. So you'd write test cases, user can click on GUI, user clicks on this button. Um, I don't know how you're going to animate your stick figure, but basically, if you have like some kind of a function guiding the various joints in the figure, you might have unit tests that say, okay, hip joint can never go too far in this direction, or neck joint can't completely go flat because then my GUI dancer would have a broken neck, or something like that. But you have a list of JUnit tests that you build up first, and then you write the code. So with this kind of an approach, I find it kind of fascinating because you don't really have anything to test yet. You're writing your code to make the test cases pass, which is something that you don't want to do typically in software engineering. But here, basically what you're doing is you're structuring your code in such a way that it matches your requirements because you write test cases to your requirements, and then if the code passes, you're actually kind of doing this nice little end around there. So the JUnit would have like placeholder functions that you would write later. Yes, so good question. If you don't have functionality to test, then you would need to write function stubs, basically. Yep, that's actually one of the approaches. We'll talk about they liken them to stoplights. So there's like a red light, yellow light, green light, and the red light's that the test case is failing with zero code. The yellow light is that it's failing with code, and then green light is that it's passing, basically. Yeah. But yeah, good insight there. But kind of one of the nifty things with test-driven development, I don't want to spend too much time on this. I just find it kind of interesting as somebody who did not do this when he was working, is that typically when you're doing a project, you write your requirements, you write your code, then you write your test cases, right? So it's separate activities. If you're doing a very agile, very test-driven development type of style, you don't have to do all that extra effort later on. You just are doing them in parallel. You save yourself a ton of time by doing these things at the same time. It's kind of to somebody who's maybe never done this before, if you're going through a testing phase of your software, it can take weeks to months. And if I don't have test cases already, it can take even longer. But if I've written them in parallel, then I already have like 90% of the work done. It's awesome from a, project management perspective. So we have our development cycle. Then we get into our QA and acceptance testing. Basically, do your test cases pass? Do your modules fit together? Did the test still pass? Does your system as a whole pass tests? Does the customer like it? We might even look at things like usability testing. So let's bring in actual users, see how they like it. Bring in target audiences and maybe target demographics. Do they like it? Here's all of our users' feedback, right? Do like beta testing, things of that nature. Feed that information back into your project team, right? So review and adapt. Maybe we have formal reviews, we'll do surveys, we'll talk about, how to get input from people basically to strengthen your project. And then you ask yourself, are you done? Or do we have to go back again and fix things? Do we do another loop of this cycle? And again, it's kind of more free form than the other styles of development because here we have so much flexibility to say, hey, let's go back to the speculate phase, right? We screwed up all of these stories, right? All of these post-it notes that are invisibly behind me that I'm kind of hand waving because that's what you get to do as a professor is hand waving and people think you're awesome or not. But what's wrong here with this set of objects we have to deal with? What's right? What do we like? What do we not like? And I keep referencing this kind of sticky note type of thing. You might have a board that kind of looks like this. Again, these are all little sticky notes. Now they will have, yeah, this is gonna be very minutia type of thing here. These cards have a specific format that you have to fill out, right? You have a title, you have what the story is, you have responsibilities, you have basically there's a bunch of little boxes you have to tick. But here you have iteration backlog in development, in test, in user acceptance testing, ready for production. And you just see all these little cards on a board. If we are, say, developing our GUI elements here, we would have cards specific to that here. Maybe one of you have done the base stick figure, okay? You have a circle and 1, 2, 3, 4, 5 lines, and that is your stick figure. I'm drawing it to the screen. Hey, let's move this card over to the testing cycle, and then we can run it through our testing strategies, right? Maybe it's very basic testing at this point because that's all we need, but we are basically moving these little pieces of our project around. And some of you might be looking at this and say, hey, what if somebody bumps the board at night while the office is being cleaned and, one of the cards falls into the trash? Well, you probably have an electronic representation of this too. But this is kind of the key thing with Agile. And this is Scrum specifically that you're seeing here. Again, there are a ton of different flavors. You might have a Kanban board. I'm sure some of you have at least heard of that. I don't have an image handy for that guy, but it starts with a K. Let's see. It's going to look pretty simple here too. It's similar to what you saw before. But you might have, and I guess I should mention too, I know that those of you that have done internships have probably worked with Jira, some of the Atlassian tools, they have Kanban stuff built into it. GitHub has it built in as well. It's not something I'm going to require you all to use, but if it is something that you are interested in, um, up, up, up. Team professors, and there we go. If you go to this little projects tab, make this a little bit bigger, you can plan out your project and sort tasks. So basically you have a lightweight Scrum / Kanban board. And I know one of the other tools that are pretty popular right now is like a Trello board. I'm sure some of you have used Trello before. And if you haven't, this is basically one way that you can handle things. Where do we have? I know I have a board somehow, somewhere in here. So I wasn't planning on looking at this, that's why I didn't have it handy. Do you not have my account? I already have an, okay, it must be some other account. Basically, you have a bunch of like flexible areas that you can set. Place a complaint regarding books delivery last week. So these are house chores, volunteering, to do, in progress, next, doing, done. Relate this to software development. Story development, implementation, testing, ready to be tested, ready to release, ready to merge, things of that nature. A little bit more flexible, but very, very powerful. And if this is something that really tickles your fancy, you can go out and get certified, become a Kanban master, a Scrum master, an Agile, or a Six Sigma black belt, whatever process you want to become an expert in. You can consult at companies and basically structure people's project teams. Probably make a lot more money doing that than straight up engineering too, oddly enough. But this is basically one of kind of the core tenets here, is that it's very flexible. Now let's take a look at one of these kind of very deep in that infographic type of images, let's look at a sprint. Okay, so here we have a product backlog, a sprint plan, a sprint backlog, a backlog, a scrum, and then a review and an increment. And then we have some very hard to see, at least on my screen, hard to see loops that bring you back here. And I'm not sure why they're using the Dropbox image for increment, but there you go. All right, so these backlogs here are basically just going to be, your Scrum board or your Kanban board with a bunch of post-it notes on it, to kind of visualize what these things are. Your product as a whole is what you are releasing. And based on what we want to work on for this particular sprint, we're going to take a subset of these items and put it into our sprint backlog. And if you have used Scrum in the past or some form of Agile, and I'm explaining this differently, again, be aware that there are multiple flavors of this. Maybe your environment chooses to implement Scrum differently. It's possible. So what are we working on for this sprint? We create a sprint backlog, and then we're going to have a Scrum team. And now this can be a self-organized team. It can be, hey, I want to help you with this sprint, or you 5 individuals, you are going to be perfect to work on this group of tasks. These 5 individuals will work over here. Your sprint outcomes will be different, but you're going to be a Scrum team. And you can go between teams too as well, depending on, again, your Scrum master in your environment. You're going to have a daily Scrum meeting, which is basically like, let's have a stand-up chat at 9 in the morning. Here's what I did yesterday. Here's what I plan to do today. Basically, that's pretty much it. Everybody does a 5-second overview of their planned tasks. Are we going in the right direction? Yes. Hey, somebody needs to take this task for today. Who volunteers? Okay, you do. Great. So you're gonna basically pick what you work on here, and then you're gonna work on it for the day. And depending on your team, you might touch base at the end of the day, or you touch base in the morning. And then once you get to a point where things are done with the sprint, right, maybe enough tasks are done or a timeline's been hit, let's review what we have and either increment our backlogs, increment our release. Maybe we have to go back and do another sprint to clean things up. Just kind of depends. But basically, very flexible, self-organized teams with a lot of, I'm going to use the term again, flexibility in choosing what they work on day to day. Can be very, very powerful. One of the other things in here too, which don't really have a slide on, but I should mention, Agile gives you the ability to explore and to fail and to not feel bad about failing, which is something that as an engineer is kind of a hard pill to swallow because you don't want to fail, you don't want to look bad. Let's keep picking on the GUI dancer team just because your team's on the top of my mind since I reviewed one of your last in-class assignment most recently. Let's say that you're going to do a sprint, right? So maybe that's how your team is structured, and this week you're working on animation. Great. So your team, since you have small teams, you all just be a Scrum team. One of you gets the wild idea that they want to try out Python, right? You're doing it in Java so far, it's a GUI element. One of you said, hey, I heard the professor talking about Pygame at one point. I'm going to take a look into Pygame, see if it works. Give me a few days, let me come up with a little demo. If it ends up being easier, we'll implement it in that. If it ends up being a major pain in the butt, I've just wasted a couple days, but at least we checked it out. And that's okay, right? That's how Agile can work. You let people explore what needs to be explored, and as long as it's not like to the detriment of the project, it may have been worth exploring. Because when you give somebody that flexibility, A, they're going to be motivated to do something they want to do, and B, maybe the gain that you get out of that little exploration is absolutely worth the time invested. Right? Maybe one of you say, hey, let's do this in Unity. Okay, I'm the only one here that knows Unity, but I can teach the rest of the team how to do it. Or we want to look at this particular, Java package for drawing. Maybe you don't use a GUI, maybe you use an OpenGL package or you use some kind of a graphics package. Somebody tries it out. Hey, this is great. You should all use it too. Right. Again, you give people the flexibility to try new things, and if you fail, You're not a failure as a engineer, you've just tried exploring something, which is it's kind of a different perspective, and I really like that idea that it's okay to try new things, which is something that is unheard of in industry up until this methodology kind of came into play. So those are from last time to today, those are basically the high level software engineering processes we have, right? From very structured in waterfall to incremental, which is, kind of in the middle, to agile, which is very flexible. And this figure is still out of the grad class, so the 641 class, but I think it is a great picture of why you would pick one process and why. And if you look at something like this, probably makes for a good type of test question, wink, wink. I'm not expecting you to memorize this table, but I'm expecting you to kind of think about why you would use one over the other. And if it's not clear why we would, any of these, what any of these are, we didn't talk about throwaway prototyping, honestly, so scratch that one out. But if I have a customer that doesn't really know what they want, so we have unclear requirements, waterfall is going to do absolutely terribly. And the reason why, if you think about it, is that waterfall is very structured, right? It's very rigorous. We have our requirements phase and then we're done. If our customer is changing their requirements, waterfall is it's set up to fail, basically, right? Whereas something like an agile methodology, you change your requirements, no problem. We'll do a sprint to fix it or to update things. So we have the flexibility there. Maybe the system is very, very complicated, right? There's a lot of moving pieces. Maybe it's a safety critical system. There is basically a lot of things that you have to deal with. Waterfall, you know, the, we didn't talk about parallel would be something that, again, we didn't talk about in class, but we had like the V model, spiral models, things of that nature. If we have a good, rigorously defined structure to a project, we can handle big, complicated things pretty easily, right? Everybody knows exactly what has to be done at which point in time. But that requires good requirements, right? It requires a very firm set of inputs. Interestingly, though, Scrum does fine too. Prototyping does pretty badly. And this is in general, right? I'm not saying this is exactly how it is for every project. There's always going to be, the exception to the common standard here. But if something's very complicated, maybe you want to try prototyping where we build little prototypes along the way. Well, if you have a big complicated project, continually building little throwaway demos is going to be a waste of time and you're not going to get a very cohesive product at the end. So you can kind of look through this table and, hopefully it makes sense where, effectively it builds on how structured is your project, how set in stone are your requirements, which process do you pick? And to me, I think the interesting thing with this figure is that if you kind of go towards the right side, and this is more like a spectrum of them, the closer you get to Agile and, some of these rapid application development technologies, that's what RAD stands for here, you don't really see any poor, like any, this is never going to work here, right? Even though waterfall, parallel, phase development, these are all good for complicated and reliable types of projects. Scrum is still fine for that too, right? So it's a little bit more, I suppose, viable for multiple types of projects. The key takeaway here, though, is that you have to pick one when your project starts. Okay, so don't be the project team that starts out doing Spiral. And then halfway through, your manager goes to an industry conference and everybody is just gushing over Agile. It's going to be amazing. It's going to save our company. You come home and then you tell your project team, we're doing Agile now. All of those processes that we started, ignore them. We're going to start with Agile. That is a great way to kill team motivation, kill a project, and really just ruin things. Pick one at the beginning. There are success stories of people who have transitioned successfully from process to process, but that is a much bigger hurdle to get over, right? Everybody has to buy into that idea, and it can be very tricky. I made this kind of blanket statement not to change in my grad class, and one of my students popped up, we actually did this and it actually worked. I'm like, that's amazing. I can't believe it. Um, I have seen lots of projects fail because they switched midstream. So success stories are always good to hear. All right, so we have another figure here from the grad class where it's going to just look like a bunch of shaded areas to all of you. But what we have here is the amount of effort in a project, and this it's called the unified process. Basically, the grad classes introduces this software development life cycle for like all software processes, Agile, Waterfall, they're all one big unified process. Here, what you're seeing though is the amount of effort at the different stages of a project, right? So you see business modeling, requirements, analysis, design, implementation, test, deployment. Those are your key software processes, right? Those are those boxes with the arrows going into and out of them. We've just kind of moved them around and added arrows based on which process we're using. But from inception to construction to transition, basically, you're looking at a positive in the time direction. So project start or phase starts, and then we kind of move on over time. Modeling and requirements, there's a lot of effort at the beginning of the project and it kind of tapers off as you go, right? Analysis and design, more towards the middle. Implementation and testing, more towards the end. So if you are looking at constructing a project team, maybe we only need the requirements people towards the beginning of the project, right? We need 5 requirements engineers from the outset. Once we start getting into design and implementation, they can be moved to other projects. And here I'm asking you to look at this figure, pretend you're a project manager, right? One of the things that you will have to do is you move up in the chain in industry. I'm not going to sit and write code all day. Now I have to start managing projects. How many people can I have on my payroll at the same time, right? Maybe my schedule and my budget are so constrained that I can only ever have 10 people. 5 of them right now will be requirements engineers, and then I can move those 5 to another project later on, bring on some testers or bring on some quality assurance people under the umbrella of this project. That sounds horribly dry and absolutely terrible to talk about because it's not the exciting stuff. But these are the things you'll have to do later on. You start getting your first management job, for instance. You go up in the ranks a little bit in a company, and hey, all of a sudden you have to manage budgets. Nobody told you you had to do that. I'm telling you right now, it's a inevitability. And configuration and change management and this kind of stuff we'll talk about starting in the next set of slides. Okie dokie. So some questions for you now, and then we'll end for the day. But everything makes sense so far? Anything unclear with all of these different technologies we've talked about? Hopefully it's all good. If anything is unclear here, think about basically what I'm trying to get you to think about is which process do we pick, right? You may have some kind of a corporate structure where everybody does Agile or everybody does V or Spiral, whatever. But if you have the flexibility to pick a process, take a very hard look at what your project is going to be. Are you building a website for a friend who is going to tell you in 5 weeks, yeah, I like your design, but instead of this basic WordPress page that you said you could knock up in 20 minutes, now it needs to be a Drupal page with the storefront, and I need to be able to dynamically update it from my phone. Can you do that? And you're like, yeah, no, we set that in stone at the beginning. Sorry. That's your waterfall model, right? Whether you're not telling them that. Or if you want to be able to handle requirements changes, okay, this was our alpha version. let's go back and redesign things and include what we learned in the beta version. That's just kind of the ideas there. Alrighty, some questions for you. So I've got a few slide-dos here, so we'll see if we can knock these out. Um, World's creepiest robot, in case you were wondering. This is the Pepper robot. It's actually used in hospitals and care homes to interact with patients. That's got creepy, dead-looking eyes. One of my former colleagues used to work with this robot, so I had to toss it in there. But it's just sucks your soul out staring at its like this little iris here is the creepiest. This one, it's not terrible, but yeah. Anyway, join the quiz. Did I make this quiz? I thought I made these short answer questions. Alrighty. So, couple of slide-dos for you. Waterfall is which type of process? Is it linear, iterative, evolutionary, parallel? What do we have going on here? It's the mouth for me, dog. It can talk. I will say that. All right, we got 6 answers, so that's good. 6 people are in it to win it. 7. Hey, look at those numbers creep up. 10. Wow. I think that's the most I've ever had paying attention in class. 12. Wow, look at that. Dang. So while some of these answers are coming in here, it does work with so that robot in particular, it's been used for like working with kids with autism to kind of, help them. And it it works pretty well. I mean, it's a nifty bit of technology. I've been wanting to either get a robot like that or build it for research, but haven't had much luck with getting it off the ground. Okay, 18 people. That's good for now. All right. 85% linear, iterative, parallel. Good guesses. The correct answer is actually linear. Right? So waterfall, there is no iteration happening. And you could look at the term iterative. We are iterating. But in the context here, iterating means we can go back and like iterate a phase. So linear is correct here. There is no going back. Next one. What about spiral? This may be considered a trick, not a tricky one. It's not intended to be tricky, but basically I said it wrong initially, so that's why it might be tricky. But if you remember, spiral is where we have basically these 4 to 5 phases and we kind of loop around them as we go. So we're basically revisiting them and making small changes. Not to throw away the answer or anything like that. Yeah. I must say I am impressed. I know not a lot of people talk in the chat, but this is probably the most responses I've ever had in a class in some of these interactions. So kudos to all of you for paying attention. Good job. Alrighty, spiral is wrong button. Ooh, yeah. So those of you that were actually listening to me last time got it wrong, so I apologize. It was evolutionary. I can see the claim for iterative. So you are iterating pieces of this thing, but the evolutionary aspect is that you are basically going through a cycle, making changes and making it stronger. And you are always going through them in a continuous pattern. Iterative would be more that you get into a phase and either it is good and you leave, or you have to make changes and keep going back. I can see the confusion. But again, I said iterative the first time too, and I always get them confused. So um, that's perfectly perfectly fine, but it is technically evolutionary. All right, last one here. How about Agile? So Agile, again, is going to be any of the subsets, whether it's extreme programming, Scrum, Crystal, Kanban, they're all going to be the same style of method. Hmm. I saw it was a great, I'm waiting for your answers to come in. I saw a great meme. It was either on like one of the college subreddits I'm on, or probably wasn't on our professors because that's just a dead zone of people who have given up on life. But it was like the starter pack for online classes, and one of them had a Google Slides game type room. Yeah, that's all I can think of when I do some of these. But okay. Then I start thinking maybe adding a game to one of these would actually be kind of fun, and then I think people probably may or may not like it. We'll have to see. All right, Agile. Ooh, more dissent here. Okay, iterative or parallel is basically where it comes between. Technically parallel. So the nice thing with Agile is that we can do different tasks at the same time. Basically, we can do them in parallel. Again, I could see the claim for iterative, but basically we may have different teams working on different aspects of our project at the same time, right? Yeah, I honestly, this is kind of a happy medium. It kind of is, there's going to be a trade-off in any way, shape, or form, right? What's iterative then? Oh, hey, look at that. Good job, Brian. I didn't realize we were going to have a top score list in here. All right, so we already did that. What is iterative? That's a great question. Bop, 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 bop. Come on. So I've got to get you guys out of here in time. Why do I keep going over time? This never happens. This is going to be your prototyping. This is going to be your V models, where basically you have a very linear process, but you have the ability to go back. If that makes sense, right? Okay. I can't believe I've held you over time again. I'm so sorry about that. But Friday, we will move on to configuration management. We'll start talking about what Git is, and be lots of fun. Anyway, office hours in a few minutes. If anybody needs to chat, it's on Blackboard. Hope you all have a wonderful day. Bye, everybody. Ooh, wait. Gotta do the thing. There we go. Haha. See ya. Oh my god, that is so loud in my headset anyway. There we go. Alrighty. Blackboard time. Just in case you're not aware, I'm intentionally leaving this up. Office hours in Blackboard. They are right here. Here. See everybody.